Hello, everybody. Today is May 19th, and we are continuing our study of kinetics and equilibrium. We are now focusing on equilibrium, and today's main focus is LeChatelier's principle. This principle explains how a system at equilibrium responds to stressors to reestablish equilibrium. So the stressors we will discuss in this lesson and a subsequent lesson will be concentration, temperature, and pressure. So ultimately what we're saying is if we change the concentration, temperature, or pressure in a system at equilibrium, and we know this system's at equilibrium because it has the double-headed arrow, if we change the concentration, temperature, or pressure, this is going to temporarily disrupt that equal rate forward and equal rate in the reverse. And LeChatelier's principle will explain how a system will respond to a stressor. So the first stressor we will talk about is concentration. Let's note, first of all, that at equilibrium, concentrations are constant because the rate of forward reaction is equal to the rate of reverse reaction. So it's a constant concentration at equilibrium. Okay, so let's talk about disrupting that equilibrium. So we can disrupt that equilibrium temporarily by increasing or decreasing concentration of one of these species. Let's look at an example. If I increase glucose, so here, let's think about this. Here are our reactants. These are our ingredients. If I increase glucose, I'm adding more molecules of glucose that will collide more frequently with oxygen and with the proper orientation to allow that reaction to go forward. And we're going to say our wording will always be that we will favor the forward reaction, or we could say this will shift to the right. So when I increase concentration, we're going to shift to the right, meaning more effective collisions will occur because there's more materials, and we will favor the production of CO2 and H2O and heat, okay? And that will occur and be favored temporarily until equilibrium is reestablished. Well, what happens to oxygen in this case? If I'm adding more glucose here, there's more here to react with the oxygen. So guess what? The oxygen is going to temporarily decrease because it's reacting with that glucose to form those products. And what's going to happen if we're shifting to the right? We're going to have an increase in carbon dioxide, increase in water, and an increase in heat. And all of this is a temporary reaction to a stressor, and the stressor is concentration. Okay, well, we can look at this graphically as well. So we have concentration and time, and this will be the initial representation of the reaction, and this will be the reaction represented at equilibrium. Okay, so in the beginning, we have X amount of glucose and oxygen, C6H12O6 plus O2. We have a certain amount of that. And as it's reacting with each other, their concentrations decrease. And in the beginning, We have 0 products though, right? That's the CO2, the H2O, the heat. As these react, they decrease in concentration and they create those products. This should look familiar to the graph I showed you in yesterday's lesson. But there's a slight difference at equilibrium. So when I complete this graph, it'll look like this. I'm not going to have them come together at the end. Okay? So this represents equilibrium because we have a constant concentration established, but it's not the same amounts. We don't have the exact same amount of water as we do oxygen, for example. But we have a constant concentration at equilibrium. And why? Because the rate of the forward reaction is equivalent to the rate of the reverse reaction. Okay, let's move on to another way to stress a system. So we're sticking with our same equation, and we're going to add this stressor. We're going to change the temperature. Now, if you look carefully, you will notice that heat is given off or liberated as a result of this reaction. So in this case, right, this is an exothermic reaction. Heat is given off. Be aware, the reverse reaction, therefore, is endothermic, right? We add heat to water and carbon dioxide to yield oxygen and glucose. So keep that in mind. So here is the rule, okay? And it should make sense if you think about it. The rule is an increase in temperature always favors the endothermic reaction. Let's think about that. As written, this is an exothermic reaction. So heat's given off. Well, what if I add heat to the system? I'm increasing that temperature. Well, think about it. I'm adding it here. This is going to favor the reverse reaction in this case. Because the forward reaction is exothermic, the reverse reaction is endothermic. And endothermic reactions take in heat. So let's write this out here. So as a reminder, an increase or a decrease in temperature will temporarily disrupt the equilibrium. And let's see how this system reacts. If I increase the temperature, I'm going to favor the endothermic reaction. I'm favoring the reverse reaction. It's going to shift left temporarily. So what happens to glucose? That's going to increase. Makes sense. What happens to oxygen? That will increase. Hopefully that makes sense. What happens to carbon dioxide and water, though? If I'm shifting to the left, these are reacting to create these. So guess what? They're both going to decrease. The endothermic reaction is favored. Well, let's look at this. Well, what if I decrease the temperature at which this system is occurring? Well, if you increase the temperature and favor endothermic, if you decrease the temperature, you're taking away that heat, you're going to favor the exothermic reaction. So what happens to glucose? You're shifting to the right. You're going to actually decrease glucose. Likewise, if we're shifting to the right, oxygen decreases. And carbon dioxide and water are going to increase. So when we decrease the temperature, we're taking away the heat, the exothermic reaction will be favored. And in this specific example, we're going to have a shift to the right. Or we could say the forward reaction is favored. That will conclude our lesson for today. We've dealt with 2 out of 3 stressors, that is concentration and temperature. Our final lesson on equilibrium will occur in a few days, and that lesson will be on pressure as a stressor. I hope you enjoyed this lesson. Have a wonderful day. Bye.